Hello, Math 2 students. This is part 3 of 3 videos that will help you to review for the test. This video focuses on intercept form. Before we can look at intercept form, let's take a look at the parent function once again. The parent function of a quadratic function is y equals x squared. The vertex is 0, 0, and the y-coordinate of any point on the parabola is the x-coordinate squared. So if your x-coordinate is -3, your y-coordinate is 9. If your x-coordinate is -2, your y-coordinate is -2 squared, or 4. If your x-coordinate is -1, your y-coordinate will be 1. If your x-coordinate is +1, your y-coordinate will be 1. If your x-coordinate is 2, your y-coordinate will be 4. And if your x-coordinate is 3, your y-coordinate will be 9. Also, there's a picture of the parent function with those points plotted on the graph. The a value of any quadratic equation controls how wide or narrow the parabola is and the direction that it opens. So first of all, when you're trying to determine how wide or narrow your parabola will be, what you need to do is just don't pay attention to the sign at first. If you see a proper fraction as your a value, your parabola will be wider than the parent function. If you ignore the sign and your a value is greater than 1, then your parabola will be narrower than the parent function. If you happen to have an a value of 1, then your parabola will have the exact same shape as the parent function. When it comes to determining what direction the parabola will open, you only need to pay attention to the sign. If the sign is negative, the parabola will open down. If the sign is positive, when you look at your a value, your parabola will open up. Now, intercept form. Intercept form of a quadratic equation is f of x equals a times the quantity x minus p times the quantity x minus q, where p and q are the x-intercepts. The axis of symmetry, to calculate that, you need to use the equation x equals p plus q divided by 2. And to find the y-coordinate of the vertex, you need to use the equation y equals a times the quantity x minus p times the quantity x minus q. Here we have a function that is in intercept form. Intercept form normally looks like this. G of x equals a times x minus p times x minus q, where p and q are the x-intercepts. So in our problem, we can see that a is 1/2, p is -2, and q is +6. So these numbers are what makes the parabola that we're about to graph unique. If one of those numbers or all of those numbers were different, we would get a different looking parabola. So by analyzing these numbers, we can see what our parabola looks like. So to begin with, I'm going to find the axis of symmetry. So to find the axis of symmetry, you have to add the x coordinates and divide by 2. So I'll have -2 plus 6 divided by 2, which is 4 over 2, and 4 divided by 2 is 2. So our axis of symmetry is at x equals 2. So if I draw that in, our axis of symmetry will look like this. All right, so now to find the y-coordinate of our vertex, we need to take our axis of symmetry, our x equals 2, and put it back into our original function. So we'll have y equals 1/2 times 2 plus 2 times 2 minus 6. And so now we do the math problem in the parentheses, and we have y equals 1/2 times 4 times -4. Now 1/2 times 4 is 2. So we'll have y equals 2 times -4, and 2 times -4 is -8. So y equals -8. So the y-coordinate of our vertex is -8. So our vertex will be at 2, -8. And that will be right here on our graph. 2 to the right and down 8. And I'm going to label that right now. Our vertex is at 2, -8. And so we have 1 point on our graph. But remember, this is intercept form. So we already know what our x-intercepts are. On this problem, our x-intercepts are -2 and +6. So I'm going to go ahead and put those x-intercepts on our graph. All right, so now I have 3 points on the graph, but I want to find out what it looks like, especially down here. So I'm going to need some more points on my graph. So what I'm going to do now is I'm going to make a table. So here's my table. I have my vertex filling the middle spot on the table, and I have an x-coordinate of 2. So 1 to the right of 2 is 3, and 1 to the right of 3 is 4, and 1 to the left of 2 is 1, and 1 to the left of that is 0. So now I need to put these numbers into my original function to find out what the y coordinates are. But remember, whatever y equals when x equals 1, we'll get the same answer when x equals 3. And whatever y equals and x equals 0, we'll get the same answer when x equals 4. So I think I'm going to begin by putting 0 into my original function. So I'll have the y value equals 1/2 times 0 plus 2 times 0 minus 6. So we'll have y equals 1/2 times 2 times negative 6. Remember, 1/2 times 2 is going to be 1. So that'll be y equals 1 times negative 6. So y equals negative 6. So we just found out that when our x value is 0, our y value is negative 6. And so when our x value is 4, our y value will also be negative 6. Now I'm going to put positive 1 in for my x values, and I'm going to find my y value. So I have y equals 1/2 times 1 plus 2 times 1 minus 6. So I have y equals 1/2 times 3 times negative 5. And so now we have 1/2 times 3 times negative 5. Since you can multiply in any order, I'm going to multiply these first. So I'm going to have y equals 1/2 times negative 15. Now, 1/2 of negative 15 is negative 7.5. So when my x value is 1, my y value is negative 7.5. And when my x value is 3, my y value is negative 7.5. Now I'm going to plot those points on my graph to make sure that when I draw the parabola, it's the right shape. So I'm going to go over 0 and down 6. I'm going to go over 1 and down 7.5. So that's 7.5 is about another halfway down. And then 3 and down 7.5. Symmetrical point right there. And 4 and down 6 gives me a symmetrical point right there. So now when I make the graph of my parabola, it will look like that. And when I check my a value is positive and my parabola opens up. That's good. And it looks like, since I have a proper fraction for an a value, I'm sure that my parabola is wider than the parent function.